All right. Hello, everyone listening remotely. This is our fifth community computer over data working group community call, and we're very fortunate to have Luke from the Spice AI team as well as Derek. And today we're going to learn a lot more about their platform in particular. It's going to be a bit of an unusual session because we had a different team that wanted to join, but they're based in Asia Pacific. So they're going to have a second call later today. We'll probably end up splicing these together. But nevertheless, I'm looking forward to hearing everything about Spice AI. And so, Luke, I'll hand it over to you and let you take it from there.
Cool. Thanks, Wes. Thanks so much for having us. I'm going to share my screen here. Set this up. Second. You guys see that okay?
Looks good.
Cool. So I was just gonna just demo a bunch of our stuff. And then I looked back at the previous presentations and no one's audio folding. And there was a bunch of really awesome presentations, high quality ones. I was like, oh, I guess I'll have to do a deck. So here we go. We'll go through it pretty fast though, and hopefully spend a bunch of time in the product. So, so who are we? Luke Kim, founder and CEO of Spice AI. And before this, I worked in Azure, built a team there called Azure Incubations, built a bunch of projects. You might have heard of one called Dapper, which is a distributed runtime for building applications. And then also worked on a bunch of developer tools and infrastructure for GitHub, Azure, and Microsoft. And Spice AI, we're an early stage startup, and we're actually a Protocol Labs portfolio company as well. And our mission here is really to make building data and AI-driven applications easy. We launched our preview of our data platform in April called Spice.xyz, and I'll be taking you through some of that today. So if you think a little bit about the history of app platforms, we've kind of gone through a couple of these stages. Might remember on-prem a little while ago now, or actually, a lot of stuff is actually still on-prem, but a lot of the applications built in that time were obviously these client server applications. Then we went to public cloud and cloud applications, and we really start to evolve into much more sophisticated distributed applications, highly reliable, scalable, and so forth. And then as like an increment on that, started to build these containerized applications and even more sophisticated applications, more reliable. And this term kind of came around called cloud native. And a lot of these applications were built on platforms like Kubernetes. And our thesis at Spice AI is that the next kind of platform that comes out is really going to be targeting what we call data and AI native applications. And these applications, just like the cloud native applications, were really native to how the cloud works in terms of this distributed nature, the scalable nature. We believe that these data and AI native applications are really going to be native to building these intelligent applications that span kind of any of these platforms. And I think that the platforms that enable these applications are still being built and still loading. One of the technologies, I think, is going to be Web3 that helps build these. So if you think about what is a data and AI native application, what we see it as is apps that act, so they take actions, but they're based on intelligent decisions from real-time data. Now, if you think about Web3 applications are already data native applications. So if you take some of that definition, they're applications that act based on real-time data, and that happens to be blockchain data and smart contract data. You could argue that a lot of them are intelligent, but maybe not in the definition of intelligent that we use, which is by really leveraging AI techniques like deep learning and machine learning and so forth. And so if you think about how you might build Web3 versions of intelligent applications, think about things like QuickBooks or Xero accounting packages. Well, how would you build that in the Web3 world with things like intelligent transaction categorization, for example. Or some of the biggest businesses today in Web2, YouTube, Netflix, Amazon, how do you build like AI-driven recommendations? So say if OpenSea wants to do NFT recommendation when you go there, how would they build that? Or even just things that we've had for years and years, like Gmail with spam filtering and fraud detection. How would you build that on, say, wallet-to-wallet messaging for protocols like XMTP? The other thing when you get into Web3 and blockchain data that I'm sure a lot of you already know is Web3 and blockchain data is painful, right? So you have to build and operate these massive blockchain nodes that, tens of terabytes going to petabytes with, chains like Solana. And you have to build all and operate this massive big data infrastructure and AI infrastructure and ML infrastructure. And you have to understand smart contracts, calls, logs, and events. And that's just like to get the basics to start making data and AI-driven applications. So a lot of work, right? So, and if you look out there, there's really no good solutions that help you with this. So there's really great analytic solutions, but these are focused on analytics, so Dune, the graph, and so forth. And really, they're not designed for massive scale training, big historical data sets, bulk data APIs, ML friendly. And so what you find is most companies try to build it themselves, but often spend a lot of their engineering time. We've heard from many companies building products on the infrastructure instead of actually the value that their products actually bring into market. So what we're building Spice AI for is something specific, not necessarily for specific to analytics or dashboarding or dApps, but specifically for bulk data applications and machine learning. And so if you think about an application, production application really needs to be very high performance. And if you think about machine learning, you need to be able to query and fetch millions of records, tens of millions of records at once to do training, to do aggregations and so forth. And our specific audience here is really developers and data scientists, people who are building applications and want it to be easy, right? So 3 lines of code to get your Web3 data into NumPy or Pandas. And so if you think about the grid that we had here before, Spice AI's focus is really on applications of machine learning, and it does query, SQL query, but it also really supports these massive historical bulk data APIs, and we're building it to be as ML friendly as we can. And so here's kind of the general platform. We support Ethereum, Bitcoin, and we run our own nodes. We index all that data, and we have more chains coming soon, Polygon, Solana, and so forth. And the idea is that you can build your applications on top of the platform and access the platform over these really high performance, low latency Apache Arrow APIs, which is this high performance columnar data format, in-memory format. And it's used by projects like Spark and Pandas. And so you can actually use these libraries as well directly on the platform and use all of these tools that you would have already used today in the ecosystem. And so with that, we'll get to the actual demo part and we'll take you through a little bit of the platform. Now, it is early access. We started building this in January, so pretty early. And so we can choose some of it, but we're still building quite a lot of it. So let me just bring up this really quickly. This is our homepage, spice.xyz. And so we'll just log in. And because we're targeting developers and data scientists, you log in with GitHub, and that's just kind of the canonical way that people in the space share. We'll probably add other developer-friendly logins later on when we're out of preview. So we are still in preview here. If you look here, it's a very simple API, but it's an application-first API. Interface. And so we're just going to go into this application here. And this is really just to help you explore the API. The actual product itself, explore the data. The actual product itself is the API. And so like other products in the space, you can just do a really quick SQL query and you'll see it's like super fast. And everything we do is aimed at being high performance, because if you're building a production data-driven application, you need it to be high performance. And so essentially you can explore the data sets that we have. We have a little bit of a data set reference here, and you can go through. We have tokens, NFTs, DeFi data sets. And if you look here in our docs, we actually have a bunch of example queries that you can go through. And so a couple of those will actually take. So here is this one, just getting the latest block number. I'm going to put that one in there. And so the latest block number I've just pulled up 878. I'm going to come over to Etherscan here and refresh that. You can see 878. So you can see real-time data that we have in here. If we continue on over to this Python tab, what I mentioned before is the goal is to make this as easy for developers as possible. So we have our SDKs, and one of our SDKs is this Python SDK. And you can see here, it's 3 lines of code, including your API key, including your query, and then you have your data in pandas. And what we've done is abstracted away the use of Apache Arrow, which is high performance gRPC connection, to the service, which means you can get all this data down super fast and just using a couple of lines of code, and you got it into Pandas or NumPy or any of these other libraries, Matplotlib, without doing a lot of extra work, and you still get all these benefits of this very high performance interface. And we also have a Node SDK too, and we're going to be building other ones like Go and Rust and so forth. The other thing that makes it really cool and easy to do is use other platforms as well. So you don't just have to use our platform for dealing with the data. And so you could pull it into your ML pipeline, something like Kubeflow, or even a Kaggle notebook. And so we have a couple of example Kaggle notebooks up here. I'll pull this down because I can't see. And so if I look at, say, one of these DEX liquidity plots over in Kaggle, I can easily do the same thing. So here we're just pulling down the SDK, and again, just a couple of lines of code. This time the query is a little bit longer, but essentially it's just a query. And now I can use things like Matplotlib with my data, and continue to have that ongoing and refreshed and super fast. So a couple of other examples of queries we can do, things like average transaction fees, gas fees, kind of all the things that you would expect to be able to do from a data platform in a space. And they should all running pretty fast, right? So here's some transaction fees, NFT API, NFTs, and tokens. One thing that we're pretty proud of is we have a very good detection for tokens. And so here we have ERC1155, and it's all automated. So if a new token comes up on the chain, we'll be able to detect it. And we kind of give you the token standard as well in our token APIs. But again, this is really just the start. We're just getting started. We're going to be working together with the community to build a whole bunch of data sets here. We also support, just like a lot of the other data providers, direct access to our nodes. So if you want to go and use our JSON RPC nodes, you can do that too. And we have other kind of value-added APIs like prices and gas fees and so forth. So that's the basic platform. And our goal is really first to provide the data in high performance bulk data way. So for example, with this API, you can go fetch 10 million rows at once. And because it's coming down this high performance Apache Arrow API, it's kind of this long-lived connection that's very efficient. You can even stream it down. And so the next step after that is what we'll talk about within the context of this group with us. Then how do you actually apply compute over that data and start processing it and doing some more interesting things with it. So let me come back to the presentation here. Come through here. So if you think about the things that we can do here, we see it in kind of 2 categories. One, we just love the idea about doing compute over data, and especially working with Filecoin and IPFS and Protocol Labs projects. And so we expect to be able to contribute to the working group, but also projects like Bakahu, which I can never pronounce, And we're going to go over to the Data Summit in Lisbon and give a talk there. Philip, my co-founder, is going to go over there. But also, we actually want to really work with the group to integrate some of the projects into the platform. So you can imagine that we would host our nodes into Spice and then enable you to do computer IPFS data there, but combine that with that queried Web3 data. So imagine that you have a job, you're querying data and saying, fetching all of the NFTs for the last year. Then you have the NFT, all that list of NFTs in your actual job. You can then take that, query the IPFS data to get the actual NFT, do some processing on the actual image, and then send the result back to the chain or somewhere else, or even generate data sets for other Spice users. And so we think that's a really great application of the project. And then you don't have to take all of this data out of the system, move it all around, especially when you're dealing with millions of rows, which is the idea for really data-driven applications and when you want to do like large-scale machine learning. So we have the platform right now. As mentioned, it's in preview. We have a bunch of pilot customers on it, all doing some really cool stuff. Everything from NFT marketing, analytics to obviously trading and financial applications, but NFT authenticity services, wallet messaging. And the other thing I wanted to mention is we're also developing this open source project to help build AI-driven applications easier for developers. And essentially, being able to use a simple API to access some training and inferencing, and we will wire up that data, that ongoing data for you from the platform. So you can say, here is a query, I want to work on this data, bring it into this runtime, now let me train and inference on that. And the longer term goal for us is to build this into the platform as well, so that we just make the entire experience of building a data and AI driven application just really easy. The data's there, the runtime's there, framework's there, and all of the ecosystem projects are there as well. So a really fast overview of the platform. You can check it out at spice.xyz. There is a wait list, but if you PM me, I'll let you in. And yeah, thank you so much for the time today.
Thank you, Luke. I can't say enough how interesting it is that Spice AI can be an enabler for other computer over data working group projects. So I love the positioning you guys have there. And could you say, when you think about the types of AI applications that will be built and interacting with things like Spice AI, do you think of it as the mode of operation as sort of a more batch style request, or does it get more scenarios where the applications will need frequent requests to Spice AI, or maybe not real time, but where on the spectrum do you think that a lot of the demand will come from?
Yeah, I mean, it's a great question. Hopefully, I think my headphones are running out of battery, so hopefully you can hear me okay. Yeah. I think it'll eventually be both. I've worked in big data platforms for a long time, and there's always this kind of notion of like big batch pipelines, obviously, and then real-time pipelines. If you think about, say, if you want to work with large scale, like hundreds of millions of NFTs, or if you want to do like a big training job, it has to be batched to some degree, right? I have to get all of this data and history and learn from it. But then if you think about, well, how do I actually inference on that model? It needs to be real time, because as new data comes in, I want to use that for inferencing on that model. So you really need to combine both of those models if you're going to be doing some type of real-time intelligent actions in the world. But it doesn't necessarily have to be like perfectly real-time, and real-time means different things to different people. So when we first set out, we were working with a bunch of financial applications, and we said, like, do you need real-time? They said, yeah, we do. And we thought that meant like HFT, like sub-second real-time, right? Then we went back and actually asked them, hey, what do we actually mean? And they said, actually, like, if you get us data within a day, like, we're not even that sophisticated. Like, our trading strategies, and like a day is real-time for us. So real-time means different things to different people. But I think you'll eventually need to combine both techniques to really build out these ongoing, continuous data-driven applications. And again, that can be like the examples I gave before. It could be, I'm going to take a whole bunch of data, train a recommendation model on how to like what NFT is a cool NFT to look at or buy. Or it could be, you know, similar like spam detection we've had for years. I have to, you know, look over a whole bunch of content, figure out what's spam and what's not. Then I'm going to need to have ongoing data to keep it updated. I'm going to need ongoing data for inferencing and so forth.
No, that makes sense. Thank you. All right. Well, I'm gonna give a chance if there's anybody else in the audience. I know we've got a bunch of other folks joining live. All right. Well, if no one has,
I'll say one thing. So in terms of that Bakakahu use case, I still can't say it. So why do you guys choose such a hard name? Like we already have customers who have looked at the project and are like, this is super awesome, but it's too hard for us to use, or not necessarily too hard, but like we want to focus on our business logic, right? And we don't necessarily have time to set up all this infrastructure. And so if we have a way to gain access to the benefits of that project, to be able to do compute over some of this IPFS data, that's awesome. And please go, you know, help do that for us. And they're already, we have a couple of customers who are already like really struggling with like massive egress amounts of data. And this would make this much more efficient, right? If we can bring that compute to where the data, closer to where the data lives, closer to where those results are from the queries and so forth.
No, it's a really interesting point, because just like in, you know, the Web 2 world, there should be stacks, there should be backend services for backend needs, and there should be Tableau of Web3 data, which, you know, in some ways you guys are going to be able to help fill that need. I totally agree. So that's a good point. It needs to be built that way, especially for less technical business folks to get value from it. Exactly.
Yeah. Well, thanks so much for having us. So.
Yes, we appreciate it. Thank you so much. And we'll get this on YouTube here shortly. One last, I guess, advertisement for the rest of the group. Lisbon Summit, November 2nd through 3rd. Luke's going to be there, so we're going to have lots of folks. Please let us know if you're able to join, and we'll have a little bit more content we'll add on here for this afternoon. But Luke, thank you so much for joining. That was tremendous.
Thank you.
All right, take care. Bye-bye.